let's move on now to Rolle's Theorem. So we need to determine whether or not, first of all, that if Rolle's theorem even applies to this guy, and then lastly, if it does, then go ahead and find its conclusion, which is find that prime where when you take that prime is going to be equal to 0. Okay, so three things in, and I'll just kind of say these if you want to write these down or whatever, but there are three prerequisites for Rolle's theorem. One is this continuous? Well, we know that if we multiply all this together, this is just going to be a cubic function. Okay, it's going to look, something like this, like as a cube. And we know from our pre-calculus days that's continuous. So check one, good. Secondly, is this function differentiable? Well, we can differentiate a cubic function. It doesn't have any holes. It doesn't have any asymptotes. So check two. Perfect. And last but not least, does f of a equal f of b, where a and b is your interval? Well, so we're given our interval right here, and so let's actually check that. Is it true that if I plug in 5 or -5, is that the same thing as -3? So that's the first thing you got to check, because if you just started this problem and you may have got an answer, but it could have been all wrong because you had to first check to see if this is true. Okay, so let's see to find out. Is it true that f of -5 equals f of -3? Okay, is that true or not? So let's first check that. So f of -5, and so let's see here. So -5 plus 5 is 0, right? Well, then it doesn't matter what I multiply, it's just going to be 0. And let's try -3. Well, if I plug in -3 right here, well, that's 0. Well, 0 times 0, or 0 times whatever is still going to be 0. So yes, this is true. So all three things worked. It's continuous, it's differentiable, and our two n intervals, when you plug them in, when you evaluate them, you do get the same value. Which means there has to exist some c such that when I take that prime, it must be equal to 0. Well, let's find this. Let's find this mystery c, the mystery mouse-tool. Sorry, guys, I got kids and they watch Mickey Mouse and they have the mouse-tool thing. You know what I'm talking about, where they say, "Oh, toodles," and it comes out and they save the day. All right, never mind. If you don't know what I'm talking about, put on the Disney Channel. You'll find out there. Okay, so let's go ahead and, I don't know, let's see. I want to find the prime of this. What would be the best thing? Let's just multiply this through. I suppose you could take the prime of this and multiply, and then the prime of this, multiply, and then prime of this. But I'm just going to go ahead and multiply this all together. So I'm going to just multiply these binomials. And let's multiply our first two binomials. So we'll get x squared, let's see, 5x and 4x, so that's plus 9x. And then 5 and 4 is 20. All right. And then after multiplying that guy right there, I'm going to go and multiply that by x plus 3. All right, so after multiplying all that together, I kind of did it on the side here. I'm just going to go ahead and just tell you what we get here. So when you multiply it all together, you would get x cubed plus 12x squared plus 47x plus 60. Hey, but if you got this problem wrong, please pause the video and multiply it all out, just to make sure that you're checking that you understand this and blah, 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 right? So all we do is just find the prime. I want to find this c, so that's why I got set to equal to 0, and then we're going to want to, solve right there. So let's set this guy equal to, well, actually, nice today, because we first got to find the prime, right? So let's first find the prime. So it's 3x squared plus 24x plus 47. Okay, there we go. Now let's go ahead and find our prime. So let's set equal to 0. 3x squared plus 24x plus 47 equals 0. Okay, this looks a little weird right there. All right. So now when we try factoring this, try multiplying by something to get that's not going to quite work there. So this is non-factorable. So we could do a number of things here. You know, like I just thought, because what I did on my paper, I did the quadratic formula, and you can do that, and you're going to get your answer. But you know what? Let's just go off another whim. Maybe let's solve this by completing the square. That'd be kind of fun. All right. So yes, you did hear me say this would be fun. Mathematics is awesomely cool and fun. All right. So let's put this 47 over here, and let's factor out that 3. So I'm solving by completing the square. So I'm going to take out my leading coefficient. I get x squared plus 8x, and then we'll leave a blank right here, and that equals a negative 47. Okay? So I want to get my cool little blank right here. So that means I'm going to take my 8, and I'm going to divide it by 2 and then square it. So 8 divided by 2 is 4. 4 squared is 16. All right? So I'm going to add 16 right here. Now, we really didn't add 16, right? We have to remember this, that since we added a 16 inside the parentheses, really this means 3 times 16. So really, we just added 48. So if I added 48 to the left side, in order to keep it balanced, I have to add 48 to the right side. See right here? This 16 really means 48 because it's the multiply right there. All right, so let's go ahead and factor the left side. So it's 3 times x plus 4 squared. And you can get that very quickly by just taking the middle number and dividing by 2. So it's 4. And if I square all this, I'm going to get x squared plus 8x plus 16. And that equals 1. All right. Hope I'm not making a mistake here. No, I didn't do it. This is looking different on my paper, but I don't know. Shoot. We'll find out what happens here. All right, let's just go ahead and divide by 3. So x plus 4 squared equals 1/3. And we'll extend down. And what else we got to do here? So let's go ahead and take the square roots. So that's going to be x plus 4 equals plus or minus radical 1/3. And finally, I'm just going to subtract 4. So negative 4 plus or minus radical 1/3. All right. So let's see. If I check my work here. Oh, yeah, so my answer, your answer may look a tad bit different. And see, this is what I got right here from my answer. I got negative 12 plus radical 3, plus or minus radical 3 whole over 3. It doesn't look like it, but it is the same. So watch this. If I do negative 12 divided by 3, well, that's my negative 4. And then plus or minus radical 3 over 3. Well, that doesn't look like that. Well, hold on here. This right here means 1 over radical 3, right? Because radical 1 is 1, and radical 3 is still on the bottom. Well, if I rationalize this by multiplying top and bottom by radical 3, I get radical 3 over 3. See, so this is the same as that. So your answer may have looked like this, but this is another way of writing that right there. So there's our C. Finally, for that answer right there. So if we were supposed to find some C, that prime makes it 0, and that value of C happens to be 2 values of C because it's at least 1 C. I'll just do one more problem here, and we want to find the value of the derivative of the function of this guy at the point 0, 0. Okay. Looks like a lot of hairiness here. Probably going to have to use the quotient rule. So basically, if I'm going to find a derivative here, all I got to do is just find the derivative and set it equal to 0, and then find what makes that value going to be 0 there. So let's go to town on it. Let's find f prime. Okay, so I'm going to find the prime of x squared, which is just 2x. And then I multiply that by my bottom. So x squared plus 121. Hold on, I think I'm going to run out of room here. Let me just, mijo. Let me just kind of see if I can grab this guy. Yeah, there we go. I'm just going to move this guy over here. Super cool beans right there, man. You can't get any cooler beans than that. And then minus our x squared. And then our derivative of this, which is just going to be 2x. Okay? And that's all over x squared plus 121 squared. All right. So maybe we'll do a little cleanup here and multiply all these things through. So if I multiply these guys over here, I'll get 2x cubed plus 242x. And then this right here just becomes a negative 2x cubed all over our denominator, 121 squared. And as you can see here, the 2x cubes are eliminated. And we just get 242x all over x squared plus 121 squared. Okay, so there's our prime right there in a pretty simplified version right there. So again, we're trying to find the derivative at this specific point. Well, I found the derivative everywhere. So if I want to find out what happens at 0, so that means I'm just going to go ahead and plug in, or I want to see what value is going to make that 0. So I'm going to do 242x equals 0, and then I divide both sides. Yeah, so what I did was I just took my numerator right here, okay, and so I get x equals 0 right there. Okay. Another way that you could have done that is I want to know what happens at f prime of 0. Well, that means just plug in 0. Well, if I plug in 0, well, 0 is on top. And this right here is going to be a big number like 121 squared, but that's still going to give me 0. So basically, the derivative at this point is 0. And that concludes problem number 4 and 5.